let's do some trig substitution. So we're going to use the substitution x equals tangent of theta, and theta is between 0 and pi over 2, to write 4 plus x squared as a trigonometric function of theta. So let's first write, we're going to use square root of 4 plus x squared. And then we're going to plug in this 2 tan of theta for x in here. So this becomes the square root of 4 plus, parentheses, 2 tangent of theta squared. And then so let's simplify that. This is 4 plus 4 tangent squared of theta. So this is square root of, let's factor out the 4. So this is 1 plus tangent squared of theta. Now thinking about our trig identities, 1 plus tangent squared of theta equals secant squared of theta. So we're going to substitute that for inside. So square root of 4 times secant squared of theta. Now when we square root, the answer is 2 secant of theta. So try this example. Use substitution, x equals 3 sine of theta, to write 9 minus x squared as a trig function of theta. So for this example, you would plug in 3 sine of theta and then square it. And so your final answer is 3 cosine theta. So last thing, we're going to rewrite a log expression. Rewrite the natural log of cosecant of theta plus natural log of tangent of theta as a single logarithm and then simplify the result. So it's a good review in our logs. So remembering when we're adding the natural logs, we're going to multiply what's inside. So natural log of cosecant of theta times tangent of theta. And so we'll simplify that. So cosecant of theta is 1 over sine of theta. Tangent is sine of theta over cosine theta. And so now this becomes natural log of 1 over cosine theta. And so that is, cosine theta is just secant of theta. So pretty fast. Try this example here. Rewrite natural log of secant of x plus natural log of sine of x as a single logarithm and then simplify the result. Trying this out, you would get natural log of secant of x times sine of x, then secant changes to 1 over cosine, and then sine over cosine is tangent of x.